Hey guys, been a while since I've done a video. Just wanted to let you know I have actually been out doing some imaging. We had a fairly long period in August and September where we had some pretty clear skies for a change. And I was out with a couple of telescopes, the 250 millimeter RedCat 51 and the 700 millimeter Explore Scientific ED102. And I was focusing on literally and figuratively 6 different targets during that period: the Cygnus Loop, the Andromeda Galaxy with the RedCat 51, and then the Eastern Veil portion of the Cygnus Loop, the Crescent Nebula, the Fish Head, and the Elephant's Trunk nebulas with the ED102. I've been targeting trying to get about 20 hours, but various things affect that, including some issues I want to talk about. And really, I don't want to spend too much today talking about these images. I'll just go over and very quickly here just what I have. I've done some processing with the Cygnus Loop, and there's a video out on it. I'm going to go back and do another version of it, but in general, I like the way it was looking. I've done the Andromeda Galaxy, I think 4 times now, and I don't like any of them, so I'm going to go back and do that one again. The Eastern Veil is one that I've just thrown together in color format here, and there hasn't been any serious processing on it yet, but I want to go back in and take care of that. But it is kind of interesting to see what the RedCat 51, the 250 millimeter telescope, gives me for a field of view perspective, and then what the Explore Scientific 700 millimeter scope gives me for a field of view. So this is just the 700 millimeter version, and this is the 250 millimeter version. And it's kind of interesting to have 2 different scopes to handle these objects at different scales, image scales. And then the rest of the data I have is just still in combined format. For instance, this is the HA data for the Elephant's Trunk. You can see the Elephant's Trunk coming down nicely here. We have the Fish Head Nebula, again, the stacked HA data, and the Crescent Nebula, stacked data, HA data for that one. Now, in this case, the Crescent Nebula, it's not really a good target for sulfur, so I was just taking oxygen data and hydrogen alpha data for that one. But I've encountered a couple of problems, and really I want to talk about some of the issues I've encountered and some of the solutions I hope that I have implemented, and these are the issues. Now, in a recent video, I commented as I went back to reuse my old ASI 120mm. This is the USB 2 version, the larger camera, not the mini version. Now that I have a new laptop, Windows 10, maybe USB 3 ports, I don't know what the issues are, but I can't use this camera in 16-bit mode. It won't be recognized by any of the imaging software, except ASICAP, of course, in 16-bit mode. So that means I have to use it in 8-bit mode, which is okay. It's a guide camera, and I could just live with it. Another option is, and speaking with the ZWO folks, I can, and they provided some software, reported me to some software where I can flash the hardware. I was a little leery about doing that, as just in case something happens during that reflashing process, I end up losing the camera altogether. So one of the things I decided I'd do is just go ahead and spend money for the ASI 290mm, the more recent camera, mini version. It's more sensitive. It's maybe a slightly longer chip, but roughly the same size chip as the ASI 120. And there are smaller pixels, so there are some advantages to having it, not the least of which is that it does work in 16-bit mode with modern ports and computers. The next issue is that I have, and I have talked about this in recent videos, stretched stars around the ED102 field of view. Another issue I deal with is significant deck backlash, which has been a known problem. It's been a problem I've had, obviously, ever since I've had the CGEM mount. This is what backlash looks like. This is a close-up of the guiding one night, and the red curve is the deck motion, the blue curve is the RA. So these bars here are the corrections that PhD2 is sending, and you can notice in this case I was in auto guide mode, meaning that it was going to correct for deviations to the south and to the north. But you can see what's happening here is the deck guiding drifts off and then finally reaches the minimum motion that I have set in the PhD2 algorithm. the algorithm starts sending commands to tell it to get back up to the center line, but nothing's happening. The mount's apparently not responding. Now the mount is responding, but there's relatively, on this scale anyway, a significant gap between the gears, and so before it can engage the gears on the other side to finally make the correction, it's got to use up that empty space in the gears meshing. And so as we're going along here, it continues to accumulate error because it's not making any corrections, and then finally it uses up all that space, and this last correction here basically puts it back on track. But now the gears are meshed on the other side, and so when it drifts in the other direction and wants to make a correction, it sees that it has to make a correction because it exceeds the minimum motion parameter. Once again, it starts generating commands, but the mount is, at least from this perspective, is ignoring it until finally it uses up all that empty space between the two gears, and it finally engages and knocks it back down into shape again. So this is completely unworkable from a imaging or a guiding and imaging standpoint. And so what I typically do, and have been doing for years now, is when I start guiding, I turn guiding off in the deck axis and just let the system drift. There'll be some residual error in polar alignment, and maybe even you might intentionally put in some small error for polar alignment if you're going to use this technique. So you let the system drift and find out which way it really wants to drift. So you need to wait a little bit of time to let the true drift develop. And then when you see, as I can see in this case, it's drifting to the south, I want to make corrections to the north. So I just say engage deck guide mode equals north, and then these commands that are sent to correct the position of the deck axis are only sent in the north direction, and the mount never really wants to drift, or the scope never really wants to drift in the north direction anymore. It just keeps wanting to drift in the south, and ever so often you can see there are a couple of commands. But actually, this is a fairly effective way of dealing with a mount that has a great deal of backlash. And in fact, I was getting, for me, decent guiding, which is usually between 0.6 and 0.8 RMS arc seconds. So I'm pretty pleased with this. It works. I'd much rather have a mount that could be guided and corrected both to the north and the south. And maybe there's some adjustments I can make to mesh the gears better, but I don't believe I'll ever get rid of all the backlash in the gears. That's just a product of the manufacturing. But anyway, this method at least provides decent guiding and does work. So I'll probably keep using it. Another issue that I encountered was a failure to download image error when the imaging camera was connected to the RedCat 51. Now, the telescope doesn't have anything to do with this error, but let me show you what that screen looks like. This happened several times during this extended imaging period. Now, this was the morning after the first night that it had happened, and I was going to take some sky flats for the imaging train. But then I noticed when I woke up that I had this message down here in the lower left and the message up here in the upper left that says the camera's busy, and it had been busy, says still waiting for images from the camera, 30 seconds, and it waits another 30 seconds, another 30. This had gone on for hours during the night. As I slept, it was not downloading images, and it just basically, for all intents and purposes, froze up during that period. And when I restarted this, it was still not working when I went to take flats, and so that's what you're seeing here. I was attempting to execute a sky flat imaging plan here, and it froze up again. So the only thing I found that would solve this is to actually physically unplug the USB 3 cable from the back of the ASI 1600 and then plug it back in, and it would work fine after that. But you have to unplug the camera, and that's a bit of a problem. If you're in the middle of an imaging session, you've got your camera cooled down to a low temperature. If you unplug the USB 3 connector, you're also effectively turning off the cooler, and that can give it a bit of a thermal shock, which may not be healthy for the camera. What I ultimately traced this down to is that I was getting a slight tug from basically a poor cable management setup that I had for this new camera or this new telescope. And so I hadn't taken enough care in making sure that I had links of cable so that a tug at one location would not ultimately be reacting against the connector. Now, the connector is not being yanked out, it's not being pulled hard, but I found that just a little bit of a jostling of the connector would cause this image download problem that I was having. And once I took more care in routing the cables and making sure I had an appropriate service loop, appropriate support points that would take all the stress off of the connector, I never had this problem again. So for all intents and purposes, this is a solved problem, I believe. It's not a problem with the camera. It's not a problem with the APT astrophotography tool software. It's really my problem, I believe, in cable management. So a word to the wise there is put some thought into routing the cables so that you avoid any possibility of the slightest tug on these connectors, because you can lose quite a bit of data as it sits there frozen up. Now, this last problem I have is really irritating, but I've noticed as I've gone back through the data and looked at it more carefully that I'm losing focus with the O3 filter only. Okay, now here's a series of images I took during the night when one of these cases where the oxygen filter came out of focus. These are all of the images, but the first image of a given filter, then the last image I took with that filter, then you switch to a new filter, in the case of the oxygen, first image, last image, first image of sulfur, last image of sulfur, and then the way I've been imaging, I've been doing a series of images with HA, oxygen, sulfur, and then repeat HA, oxygen, sulfur, repeat HA, oxygen, so that I'm getting the image of the target over a consistent range of altitudes for each filter. So I don't want to, for example, penalize S2, the sulfur data, when I'm close to the horizon, so I like to break it up. So anyway, that being the case, let's look at these. This is basically the first image I took. This is HA. We're focused in on some stars. There'll be a meridian flip here that will change this view, but for all intents and purposes, we're looking at the focus of these stars, which looks pretty good here. Last image of HA looks okay. This is the first image of oxygen. It kind of looks okay, maybe not as good as the HA. Now, I'm probably beginning to lose a little bit of focus. I'm moving towards the meridian. I'm not there yet. Then I go into sulfur. It looks pretty good. Again, the last image of the sulfur looks pretty good. And now we do a meridian flip, and we're back onto HA here. That's the first image. The second image of HA, and now we're into oxygen, and we can start to see we've really taken a hit now in our focus. You can make out that we're starting to get that telltale donut type shape. Some of the smaller or fainter stars, we're losing them altogether. If I go back to HA, you can see we had fairly nice pinpoint stars here, and they are all but obliterated with the oxygen filter. And it's not getting better here. That's the last image with oxygen. Now we're back to sulfur, but it's back in focus. And again, focus. HA, oxygen, we're more out of focus, maybe a little more out of focus. Back to sulfur. And we seem to still be in focus. So you get the idea. It's not that the whole system goes completely out of focus. I'm just losing focus in one filter. Now, one of the things that I noticed in again, going back through these images is I need to do a better job of focusing anyway. For example, the way that I have been focusing, I've been doing this in APT with the Bahtinov mask and the Bahtinov focus aid that is in APT. Here's an image, for example. I usually take a final screenshot of the Bahtinov mask image. So here's what I would be looking at through the camera, and then I would bring up the Bahtinov aid, and I would use this in real time. And now you can see I can move it around and get different numbers. But basically, this is what I would aim for, right? I'm focusing, changing the focus, and trying to get this number down to 0. And here it's telling me that focus is very close. The problem is that I have this image set for it to fit within the available image space on the laptop, and this is not the correct way to do it. These parameters that you enter in here, the focal length of your imaging camera, the diameter, and the pixel length, all are numbers that this algorithm is using to tell you whether you are close to being in focus or not, but it's assuming that the pixels that it's looking at, which are actually the laptop screen pixels, not the actual imaging camera pixels, it's using a compressed pixels because the image has been compressed to fit on this within this area. The smarter thing to do, and going forward, this is what I'm going to do, is instead set this in the mode of the one-to-one scroll mode, where now we have a much larger image, and the pixels are now one-to-one. So the pixels in the imaging camera are the pixels in the image here, and this is what I'm actually getting. So I thought all this time that I was close on focus, when in fact when using an image at 1-to-1, I'm actually pretty far apart, pretty far from focus, relatively speaking. So I'm more than 2, in this case they call it pixels, out of focus. I've also confirmed this with the actual Bahtinov Grabber software, which is what this algorithm is, but using the actual Bahtinov Grabber, I can get these same kinds of numbers. For example, let me pull that up. Okay, so let me knock that off, bring the Bahtinov Grabber software up, and focus on, I can make a larger box. And you can see these lines follow match the diffraction spikes quite well, which is the first thing you want to check. If they don't match up, don't bother looking at anything else. And now you go over here and the focus error is 3.58 pixels. Now the Bahtinov Grabber in the Bahtinov 8 and APT was telling me 2.6, but that's just variation in the tool. Also, I'm able to get a larger window for the Bahtinov Grabber software than the image window available in APT. But what this is telling me is that I'm not within critical focus. So going forward, I think I certainly need to do a better job with focusing, as we just saw. I don't think this is a wavelength issue. I know I'm having the issue with the oxygen filter, but not I'm having the issue with the oxygen filter, but not the sulfur or the hydrogen alpha, which are both on the red end of the spectrum. Oxygen is more in the blue-green area. So perhaps I can try, and did try this a couple of times, just focusing with the blue filter. But I think focusing with the blue filter, maybe even the oxygen filter if it's a really bright star, and doing a better job with using the one-to-one pixels and maybe even the Bahtinov Grabber software directly as opposed to within APT, do a better job focusing. Another thing that is, I'm sure, probably a player here is that the focuser is shifting as more and more as the telescope approaches the meridian. More and more weight of the camera is now applied axially along the focuser, which I'm sure is having an effect. It's not enough to disturb the focus of all of the filters. It's just the oxygen, and maybe it was just the one that was on the verge of not being in focus, so it was the first one to go. And maybe if I do a better job of focusing and focus on a star close to the meridian where I can, maybe those two things can help out. Another thing I was curious about, maybe the O3 filter was loose in the holder, and so that as you approach meridian, it just kind of fell slightly and shifted out of focus, but I checked it and it was fine. In the long run, I'm going to give up on this and probably just get an electronic focuser. I like the ZWO product, but I don't think their mounting bracket is compatible with the underside of my focuser, so I don't believe I can mount it without having an adapter built for it, which frankly would probably cost as much as the focuser. So I'm going to wait on this a little bit. So the next time I get a chance to go outside, I'm going to try this focusing technique and just take a lot of oxygen data, because I lost a lot of oxygen data on the on the 4 targets that I was imaging with the ED-102. But anyway, I just wanted to kind of fill you guys in on what I've been up to and some of the issues, and maybe you've encountered some of these. And hopefully one day I'll get some more oxygen data and be able to finish up imaging these targets, and we can actually talk about color images for a change. All right, guys. Thanks for hanging in there. Talk to you later.